Welcome back, students. So, for the group practice, I said I prefer to do it without graphing. Here again, we're going to do it without graphing. This is a pretty simple example because we did the last one, and this is going to follow the same exact way without graphing. Now, we can also put it in the calculator, and we'll see that it's actually another one where the numbers are perfect, but not necessarily. It's not always this way. So let's do it this way, real quick and easy. Okay, so in order to find the zeros, I need to solve for m. M squared minus 36 equals 0. And again, we remember our algebra. Inverse operations. If I do something to one side, I want to get rid of this 36. I want to get everything away from the m. I have to do it over here. Negative 36 and plus 36, gone. M squared equals 0 plus 36 is 36. Next step, I got to get rid of this square. To get rid of the square, you got to find the square root. So that's the inverse operation of that. It's a square root. So m squared is just m equals, well, the square root of 36. Now, I'm going to say this. The square root of 36, I put it on my calculator, and I remember the square root of 36, the calculator was going to tell me it's 6. Now, this is not the right answer. It's one of the answers. There's two answers. Two. Not one, but two. We have to remember there's two ways you can get 36 by squaring. I could do 6 times 6, which is 36. But I can also do negative 6 times negative 6. And again, I will get positive 36 because a negative times a negative is a positive. So in order to say what are the two solutions, one has to be positive and one has to be negative. So you use two solutions of positive 6 and negative 6. Now if you want to go on a calculator and check it, like our friends over at www.desmos, and I want everyone to have the Desmos app on their phone, unless you have a graphing calculator like me at home. Next step, I'm just going to do this. Y equals, oh look, there was our last one from before. I just got to change one number. 3, right? X squared equals 36. I graph it. And where do you think the two places is going to cross? Negative 1, 2, 3, 4, 5, 6. And positive 1, 2, 3, 4, 5, 6. Now, the one problem with this is what if the number wasn't 36? Let's take another number. We have m squared minus, let's do 30. It's like a nice round number. Equals 0. Okay. Do the same thing. Inverse operations. Add 30 to both sides. That cancels out. We're isolating the variable. To get rid of that square, I have to square root. And if I just do 1 to one side, I do it to the other side. M squared becomes m. And then square root of 30 is a very, very interesting number. Square root of 30 is this number. 5.47722557. How are you going to make this very accurate? So if I look at this here, so if I graph this same problem, here's our two answers. One's here, one's here. They're between negative 5 and negative 6 and positive 5 and positive 6. Can I tell what exactly that is? Not really. Here, not really. It's a guess. I'd be saying it's something like 5.5. Now, of course, you can't see this because I need the light on. Sorry. I'll show it better here. It's somewhere between 5.5. So, why is it better to do it mathematically? Because then I have the correct answer. I could say it's plus or minus, depending what they want me to round to. Let's say 5.48. It's not quite 5.5. It's not quite 5.49. It's kind of somewhere in between this little number. If you look at the calculator, you're only going to be guessing. You can't do that. Trust me, do it this way. These are exact numbers. They work really nice.